Topic 4 is about writing equations for parallel and perpendicular lines. So we're going to start by reminding ourselves what we already know about parallel and perpendicular lines, and then just combine that with what we've learned about writing equations. So it says, remember, what do you know about the slopes of parallel lines? Well, hopefully, if you remember, parallel are lines that never meet. And if that's the case, that means that their slopes are the same. Perpendicular lines, however, meet at a right angle. And when that's the case, the slopes are opposite reciprocals. Remember that the opposite refers to the opposite sign, and reciprocal is what reminds you that the fraction of the slope is flipped over. It's actually run over rise. So let's keep that in mind as we move forward. So number 1 says write an equation in slope-intercept form for a line passing through the point -3, 1 and perpendicular to y equals 1/3 x plus 2. Well, if you think about that writing equations flow chart, it talks about the slope and then it has these arrows and you kind of have to go through this process. Looks something like this. The first part is to find the slope. Well, if I ask you what is the slope, you may say, oh, it's 1/3. No problem. Except that's the slope of this line. The instructions are to write an equation. Well, they don't want you to rewrite this equation. They've already given it to you. They want you to write a new equation. So we want to make sure that we have the slope for the new equation. So let me reread the problem again. Write an equation for a line passing through blah, 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 perpendicular to 1/3 x plus 2. So if the slope over here is 1/3, the perpendicular slope would have to be opposite reciprocal. Opposite sign of -3, flip it over, and we'd have 3 over 1, which is really just -3. Okay, so the perpendicular slope would be -3. Okay, so thinking about that flow chart, again, I've got the slope, and then I have to decide, do I have the y-intercept, or do I have a point? Well, again, you may say, oh, yep, I got the y-intercept. But that's not the equation we care about. We're trying to write a new equation. So we don't have the y-intercept. We have a point, -3, 1. So thinking about that flowchart, we're going to be going down that right-hand side where we have to use point-slope form. So I'm going to write y minus y1 equals mx minus x1. So y minus, what is y1? Well, it's the y value from our point. So in this case, it's the 1. Equals, what is the slope? Well, it's the perpendicular slope that we found a second ago, -3. Then x minus, what's the x value from the point? -3, so that makes it a +3. Then we distribute and carry on, and we should have our equation. So we get y minus 1 equals -3x minus 9. Add the 1, and we get y equals -3x minus 8. I'm boxing it in because I went back and I saw that it said they wanted the equation in slope-intercept form, and we did that. So really, the majority of that problem you already knew how to do. It was just the fact that when it started, you needed to make sure that you were using the correct slope. So we'll do another one, but this entire notes page really is a day that you could probably do on your own and just check back with this video as you work. If writing equations has been a struggle for you, then maybe continue to watch because this is really a review of how to write linear equations. All right, so number 2. Write an equation in slope-intercept form. That's encouraging. We don't have to go to standard form. For a line passing through the point for -8, there we are again, a point, and parallel to y equals 4x plus 5. Okay, so again, thinking about that flow chart, I have to start with the slope every single time. Okay, I see a slope here that is a 4, but is that the slope I want? Well, again, they say that we want a line that's parallel to that line. Well, then that means that we want to use that same slope. M is going to equal 4, okay? Now really, once I've done that, I'm done with this equation. I've got the slope out of it. I don't care about it anymore because I'm trying to create a new line, a new equation, okay? So I've got my slope. So then I look through to see, do I have a y-intercept or do I have a point? And in this case, I have a point. So y minus y1 equals mx minus x1. So my y value here is -8. My slope we found a second ago over here on the left is 4. The x from the point is a 4. So now I distribute and find my equation. So y equals 4x minus 24. Okay, and again, they wanted slope-intercept form, so it's good to stop there. All right, one more, write an equation in slope-intercept form for a line passing through the point. So again, they're giving me a point, not a y-intercept. And perpendicular to, that's important, 4x minus 2y equals 12. Okay, first step is always to find the slope, and I'm going to get it out of this equation that's been given to me. Okay, now, if you watched the video that I created about standard form, I emphasized that you cannot find a slope in standard form. You cannot just look at it and automatically say, oh, it's the 4. Oh, it's the 2. You can't do that. You have to make sure that you rearrange the equation so that it's written in slope-intercept form so that we can find the slope. So before I'm able to pull out whatever m is here, I need to move things around so that this looks like y equals mx plus b. So I'm going to move that 4x over. So negative 2y equals negative 4x plus 12. I just subtracted 4x from both sides. Then I need to divide both sides by negative 2 to get that y by itself. So y equals positive 2x minus 6. Remember, this negative 2 gets divided by both pieces. Now that it's written this way, I can confirm the slope is 2. Okay? Now, that is the slope for that equation. Let me go back and read my problem. Write an equation, blah, 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 that's perpendicular to that. Well, then I don't want to use 2, right? I want to use a perpendicular slope. So I need to change the sign and flip it over. So I need to have a negative. 2 over 1 flipped over is 1/2. That is actually the slope that I want to use to continue my problem. Okay? In fact, I'm going to erase my circle here just so I don't get confused. The negative 1/2 is what I really want to focus on. Okay? So thinking about that flow chart, again, I've kind of given you the visual up here. I've got the slope, so I have to decide, do I have a y-intercept or do I only have a point? And in this case, I only have a point. So I'm going to have to use y minus y1 point slope form. So y minus, my y point, or my y value is a 4. The slope I want to use is negative 1/2. X minus, the x value here is 8. So now I distribute, add my 4 to both sides. So y equals negative 1/2 x plus 8. That is going to be perpendicular to that line they gave me, and it's going to go through the point 8, 4. Alrighty, now the next two are a little bit different. It says write an equation in slope-intercept form of a line that passes through negative 2, 3. So they're giving you a point here and is perpendicular, that's important, to y equals negative 5. Well, when you see y equals negative 5, hopefully at this point you're really training your brain to automatically think, okay, that's a HOI. That is a horizontal line. And if it's a HOI, I can already picture it in my mind. It's a horizontal line that looks like this. Well, if I want an equation of a new line that is perpendicular to that one, well, what is it going to look like? If I want a line that's perpendicular, that means that it is going to be a vux. It's going to be a vertical line. And if it's a vux, that means my equation has to start with an x. X equals. Well, if it's going to go through the point, negative 2, 3, let's just say that that's, I don't know, right here, doesn't really matter. Well, what would x equal? Well, x equals what x equals. Look at the coordinate. The x value is negative 2. Okay? Every point on this line is going to be negative 2 something, negative 2 something, negative 2 something. So our vertical line there is x equals negative 2. Okay? If that was a little bit fast and furious and you're thinking, what just happened? We got another one, so stay tuned. So number 5, same kind of story. It says write the equation in slope-intercept form of a line that passes through 4, negative 2 and is parallel to y equals negative 7. Well, again, this equation right here is a HOI. There's no x written in there, so we know it is a HOI. It is a horizontal line. Okay? So then they give us a point that it passes through, 4, negative 2, and they want it to be parallel. Well, if it's parallel, that means that we're going to have another HOI. Another horizontal line. And if it's passing through the point 4, -2, well, that means for this HOI, which means the equation has to be y equals, I'm going to look at the y value, right? The y value here is a -2 because this point is going to be something -2, this point's going to be something -2, etc. Okay? So whenever you have HOIs and VUXs, it's just really important to write down those little terms, HOI or VUX, because it really clues you in onto what letter you're going to write down for the equation, as well as what coordinate you're going to look at to form the rest of your equation. So as soon as I saw my initial equation was a HOI, and it was going to be parallel, which means it's a HOI, I immediately go ahead and write down y equals. Then really, once I've written y equals, I'm really saying y is what? Well, I go look at my coordinate. Y is -2. Okay? There's a few more of those on the next page, so we can keep practicing. Okay, write an equation in slope-intercept form for the line that passes through 1, 1 and is parallel to the line graphed on the right. Okay, I'm going to highlight this parallel and passes through 1, 1 because those are important pieces of information. Thinking about that flow chart, I want to start with the slope every time. Well, if I want a line that is parallel to this one, that means I want the same slope as this line. Well, how do I get the slope of that line? I just look at it, right? I rise and I run. So that looks like a perfect point. Let's see, that looks like a perfect point. I can do a few of them just to test it. So rise would be 1, 2, 3, and I run 1. And really I can keep testing that. 1, 2, 3, run 1. So my rise over my run, 3 over 1, and it's positive. So if I want the same slope, I know that my starting slope is just a 3. Well, then I think, okay, again, flow chart, do I have a y-intercept or do I have a point? You may think, oh, look, Ms. McWilliams, you have a y-intercept, but that's the y-intercept for this line. We don't care about this line. We just needed to steal his slope. We're trying to write a new equation. And for this new equation, all we have is the point 1, 1. So we need to go through and use 1, 1 as our coordinate. So I distribute, I add that 1 over, and we get y equals 3x minus 2. Okay? This looks like a lot, but really number 7 is just a big old problem. It says, which of the following describes a line passing through 3, 3 that is perpendicular, it's important, to the line described by 3x minus 5y equals -10. Well, one thing you could do, because this is multiple choice, is you could go through and you could plug in 3, 3 to each of your answer choices, okay? However, I would suggest on a problem like this, especially on your EOC, just go ahead and work it out the long way and then look at your answer choices to see which one matches with what you have, okay? So, and really you can already tell, at least in the graphs, 3, 3, we're good there, 3, 3, we're good there. So it's not going to necessarily be a easy process elimination, so you might as well just go ahead and do the process. So we want a line that's perpendicular to this guy. Well, in order for us to find the opposite reciprocal slope, we need to first figure out what this slope is. So I need to rearrange the parts of this equation. So I'm going to start by moving that 3x over. So -5y equals -3x minus 10. Need to divide the whole thing by -5. So y equals positive 3/5 x plus 2. So that's the equation that they've given me here. Now I can see that the slope is 3/5. Well, if I want a line that's perpendicular, that means that 3/5 needs to become -5/3. Okay, that's going to be the slope that I'm going to focus on for my problem. Well, that alone, looking at your answer choices, means you can eliminate both C and D because their slopes are not right. This 5/3 is positive, which is what we don't want. This is 3/5, so it's more of a parallel slope. We want -5/3, so I know C and D are both out. So let's just check the slopes of A and B because they clearly are different. We don't even have to find the y-intercept here. So on letter A, let's find a perfect point. It looks like this y-intercept's pretty good. And let's see if we can go down 5 over 3. So down 1, 2, 3, 4, 5, and over 1, 2, 3. There's nothing there. So I'm thinking this one is incorrect. Okay, let's check B. Here's a nice pretty point. It's on the y-intercept. So down 1, 2, 3, 4, 5 over 1, 2, 3. There we go. Let's test it one more time. 1, 2, 3, 4, 5 over 1, 2, 3. So I'm thinking B is the answer. If you want to, you can confirm by doing point slope form with the slope that we found, and we should get a y-intercept of 8. So if I distribute, I get a 5 there, and if I add 3, I do in fact get an 8 for my y-intercept. Okay? All right, number 8. Number 8 is one of those problems where if you have been confused this entire lesson, I would suggest that you just don't even listen to number 8 because it's kind of like a challenge problem, but this is not something that is essential for you to understand or know in order to be successful on today's lesson. So, if I explain number 8 and it just completely rocks your world, don't even worry about it. It's more of just an extension of what we're learning. So the lines described by y equals 5a plus 3x and y equals negative 1/2 x are perpendicular. What is the value of a? Well, I know that my goal is to find a. A equals. Where's the a? The a is right here. Okay? Well, great. Looking at that, I know that there's some people who are thinking, okay, I need to distribute my x, I need to do some other things, but you're already thinking about it too hard and not through the lens of today's lesson. Today's lesson was about parallel and perpendicular lines. Well, if I know perpendicular lines have opposite reciprocal slopes, what can I do with that? Well, my slope for the second equation is negative 1/2. There's nothing weird about that. My slope for the first equation, we don't totally know, but we know it has to be this piece in parentheses, 5a plus 3. If those two slopes are supposed to be opposite reciprocals, well, let's just focus on negative 1/2. What would be the opposite reciprocal? It would become a positive. We'd flip it over and it'd be 2 over 1. So really just 2. That means that this is supposed to be 2. Well, now, if I hadn't given you any other information for the problem and just gave you this, that's a very simple, just two-step equation to solve. So let's go ahead and subtract 3. 5a has to equal negative 1. Divide by 5. A is negative 1/5. Okay, so this is one of those problems that you could very easily look at and be completely overwhelmed or confused, but you have to remember what the lesson is about. The lesson is about the slopes of parallel and perpendicular lines and how those equations interact. Okay, the rest of this page, just 4 problems, and they are all about Hoyes and Vuxes. If you look at each problem, it says x-axis, x-axis, y-axis, y-axis. I would try to get a visual in your mind of what the axes look like, the axes, if you will. So just a reminder, this is your coordinate grid. This is the x-axis, and this is the y-axis, okay? So number 9, it says write the equation of line that passes through the point 2, 4 and is parallel to the x-axis, okay? Well, parallel to the x-axis, that would be a horizontal line, okay? Well, what are horizontal lines? They are Hoyes. So if I need to write an equation, it's going to be y equals because of the y in Hoy. So y equals, what does y equal? Look at your point. Y is 4. What is the slope? Well, we already said if it's a Hoy, right? The slope is just that 0. Okay. Number 10, write the equational line passing through the point 3, 9 that is perpendicular to the x-axis. Okay. Well, again, looking up at this diagram, perpendicular to the x-axis would be a vertical line, a Vux. That means my equation has to be x equals, then I go to my point, xy, and I see that x is 3. Literally is in the point. The slope, well, if it's a Vux, that means the u tells us that the slope is undefined. Okay? Same thing for these next two. I'm going to draw a coordinate grid just to remind myself this is the x and this is the y. So write the equation line passing through the point 6, 12 that is parallel to the y-axis. Here's my y-axis, so parallel would also be vertical, a Vux. So x equals, the x here is 6. Slope, because this is also a Vux, would have to be undefined. And then finally, write the equation of a line passing through the point negative 4, 10. that is perpendicular to the y-axis. Well, here's the y-axis. Perpendicular would be ahoy. So y equals, what is the y over here? It's a 10. My slope would have to be 0 because we're talking about ahoy. All right, as always, if you have any questions about writing equations for parallel and perpendicular lines, make sure to reach out to your teacher or maybe stop by the tutoring hub. All of our math teachers will be happy to help you.